let's do a third method for finding the slope of a line. We talked about how to find the slope of the line if you're given the actual graph, and we talked about how to find the slope of the line if you're given 2 points. But what happens if you're just given a table of some x's and y's, of your inputs and your outputs? How would you figure out the slope that these points make if you're just given a table? Well, probably the easiest way to do is, well, maybe not easiest, but one of the kind of simplest ones is just to make xy points out of these, because then you have 3 points and you can do the method that we just covered. So this would be the point 0.02, the point 1.4, and the point 2.6. And from there, you could find the slope of the line just using our formula, change in your y's over change in your x's. Oops, that's a 2. And then you could pick 2 of these points to plug them in, any 2 of those points. I'll pick maybe the first one and the third one. And I'm going to have this one 0.2 and that one 0.1. So I have 6 minus 2 over 2 minus 0. Then that is 4 over 2, which simplifies to be 2. So that is one way that you could find the slope of the line given these. Another way you could think of it is just see how are your x's changing in comparison to your y's. So I take a look over here. I go from 0 to 1, I'm changing by 1. I go from 1 to 2, I'm changing by 1. Now let's see what my y's are doing in comparison. I go from 2 to 4, changing by 2. And then I go from 4 to 6, I'm changing by 2. And so I notice that every time my x's increase by 1, my y's are increasing by 2. And slope, and again, is just comparing your y's to your change in your x's. So this is saying every time my y's change by 2, so again, change in your y's, my x's are changing by 1. So that would, again, be a slope of 2. Let's go ahead and do the second example. Here I have another xy table. I have the points, and I will go ahead and make coordinate points out of these. I have the point 2.3, the point 4.6, and the point 6.9. I can go ahead and do my change in my y's over my change in my x's. Again, I'll do my first and my third point because that's what I feel like. I'm going to do 9 minus 3 over 6 minus 2, and that becomes 6 over 4, which can reduce to 3/2. And then I can take a look at it another way, and I'm going to see how are my y's changing and how are my x's changing. Let's see, in this case, my y's increase by 2. And from this point to this point, my y's increase by 2. And from here to here, my y's are increasing by 3. And from here to here, my y's are increasing by 3. And, oh my goodness, so my slope, again, is talking about the change in my y's over the change in my x's. And this little triangle here, in mathematical terms, that's just talking about change. That's our abbreviation for change. So change in my y's over change in my x's, which is a fancy way of saying finding the difference in my y's and finding the difference in my x's. These things are saying the same thing. So my y's are changing by 3, a positive 3, every time that my x's are changing by a positive 2. So I have a slope of 3/2 and 3/2. Either way I do it, I can find a slope of 3/2 from this table.